Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 3, Regression Testing. Now, what does regression testing entail? Thoughtful planning, a thoughtful development of the test to cover all the possible permutations of what needs to be implemented will actually help plan my design as I move forward in the project. 2, it will reduce development time by creating a set of tests that, if I fail, will isolate potential code or circuitry that I'm trying to design, so will reduce my debug effort. 3, validation. As I develop additional code or additional features in my project, it will revalidate that I have not broken anything that I designed previously. So regression testing is very important and will actually reduce your time moving forward in this project, as well as this process will help reduce your time in future programs as well. This is analogous to what you would do in software engineering, which would be unit test, where you actually create the test beforehand, and then you write your program to pass the unit test. Now let's go into Codasip Studio and see what you'll be doing in this assignment. To start this project, you will be importing 2 new projects. The first one is assignment_3 IA_RISC-V32I. It has built-in errors that a proper regression test should find. The second project is risk_test. This will be your template that you will be using for this assignment. Now let's first take a look at risk_test. Now this test is broken into multiple sections, and they're ordered in a proper sequence that will help you in the future assignments, starting with assignment 5, 6, 7, and 8. Now, the first test, as an example, I'm going to show you, it has a header file. Each one of these has a header file, or not a header file, but a set of comments to help you figure out some of the unique features that you need to test to make a proper regression test for that set of instructions. For example, the immediate operations, the immediate is a signed immediate. So you need to test both positive and negative values. Now, when we take a look at these comments, there will be a lot of information to read and gather from it. But when you're actually creating the code, you should also have comments yourself. For example, when you write an instruction, you should actually make a comment of what that instruction will actually do. Now, I want you to make a note, because this regression test will help you in your cycle accurate model. So 5 instructions later, or 5 cycles later from your instruction, you should have a comment also of what register is changing and what's its new value. For example, this first instruction on line 35, 1, 2, 3, 4, 5 is going to change the value of the X2 register to the value of 2, matching my comment. You need to do this so that you can actually follow along on this regression test as you move forward to help you validate your cycle accurate model. Now, once you finish each one of these sections of code and you actually pass the sequence of code, and you'll somewhat know whether you've got a decent regression test if you've located the planned failure. Now, after I've located the planned failure, how do I move past it? Because I've actually indicated. And so we've added a feature in this assignment 3 IA model to disable the failure, so then you can actually pass through that in future runs of your model. So to do that, go to assignment 3, and if you open ipconfig, you can see that there is a failure plan in each one of these, the I types, the R types, all the different type of operations. There's a planned failure. Once you've located the failure, you're going to type in false in ipconfig, save the file, go back to assignment 3, and regenerate the IA model. You'll be doing this for each of the set of segments of tests that you'll be performing. If you like this video, please subscribe to this video below so that you'll be notified when future videos are published. Good luck!